Imagine a burger that cost €250,000 in 2013 and today costs just £7. That's not inflation in reverse. That's the food revolution that's dividing continents. Welcome back to Curiosity AI, where we explore the scientific breakthroughs that are reshaping our world. I'm here with a story that perfectly captures how technology can both unite and divide us in the most unexpected ways. Today, we're diving into one of the most polarizing food technologies of our time, lab-grown meat. While Europeans are pioneering the first legal tastings of meat grown in laboratories, American states are banning it outright as a global elite conspiracy. This isn't just about food preferences. This is about fundamentally different visions of the future. We're witnessing a technological revolution that has achieved something truly remarkable, a 99.997% cost reduction in just over a decade. That burger that cost €250,000 in 2013 can now be produced for approximately £7.20. To put that in perspective, that's like a luxury car costing 50 cents. But here's what makes this story fascinating. While the technology is advancing at breakneck speed, the world is splitting into completely different camps. Some countries are embracing this as the future of sustainable food production. Others are criminalizing it. This divide tells us everything about how different societies approach innovation, tradition, and the future of food itself. Let me explain what lab-grown meat actually is, because there's a lot of confusion and misinformation surrounding this technology. Lab-grown meat starts with a tissue sample from a living animal, roughly the size of a sesame seed. Scientists then isolate stem cells from this sample and place them in bioreactors, essentially controlled environments that mimic the conditions inside an animal's body. Think of bioreactors as sophisticated incubators that maintain precise temperature, pH levels, and oxygen concentration. The cells are fed a nutrient-rich growth medium containing amino acids, vitamins, minerals, and growth factors. Everything they need to multiply and grow into muscle and fat tissue. The breakthrough that changed everything was eliminating the need for fetal bovine serum, an expensive component that previously made production costs astronomical. Companies have developed animal-free alternatives that cost as little as 7 cents per liter, compared to hundreds of dollars for the old method. But here's the really clever part. Artificial intelligence is now optimizing this entire process. Machine learning algorithms analyze thousands of variables simultaneously, predicting which growth factor combinations will maximize cell growth while minimizing costs. What used to require years of trial and error can now be optimized in weeks. The result is meat that's molecularly identical to conventional meat, but grown outside the animal's body. It's not plant-based meat trying to imitate the real thing. This is actual animal tissue, just produced through a completely different process. The breakthrough moment came in August 2013 when food critic Josh Schonwald took the first bite of the most expensive burger ever created. Developed by Dutch scientist Mark Post at Maastricht University, this lab-grown patty cost €250,000 and required 2 years of development. The verdict was cautiously optimistic. Close to meat, but not quite there yet. That moment marked the beginning of a revolution that would make computer processing power improvements look sluggish by comparison. Fast forward to 2025, and companies like Believer Meats now produce lab-grown chicken burgers for approximately £7.20. That represents a mind-blowing 99.997% cost reduction in just over a decade. But the real breakthrough isn't just the cost reduction. It's the scale that's now becoming possible. Facilities under construction feature bioreactors with capacities measured in hundreds of thousands of liters. When operational, these facilities could produce millions of pounds of cultivated meat annually from single locations. The Netherlands made history in July 2023 by becoming the first EU country to legally permit public tastings of lab-grown meat products. This wasn't just a regulatory decision, it was a critical step that enables companies to gather consumer feedback before full market approval, accelerating the entire development process. The Dutch government has invested 67 million euros in cultivated meat research, more than any other European nation. They've created open-access scale-up facilities, where startups can transition from laboratory-scale production to industrial volumes. Here's where this story becomes a fascinating study in contrasting worldviews and the geopolitics of food innovation. While the Netherlands pioneers legal tastings and regulatory frameworks, the United States presents a completely different picture. The federal government has approved companies like Good Meat and Upside Foods to sell cultivated meat products through the FDA and USDA. But several states have moved to ban the technology entirely. Florida led the charge in May 2024, with Governor Ron DeSantis signing legislation criminalizing the manufacture, sale, and distribution of lab-grown meat. He framed the ban as pushback against the global elite's plan to force the world to eat meat grown in a petri dish. Alabama and Mississippi quickly followed with similar legislation, creating a patchwork of regulations that fragments the American market. The irony is striking. Products declared safe by federal agencies are now illegal in states that claim to champion free markets and innovation. Meanwhile, Italy has implemented a blanket ban with fines up to 150,000 euros, despite surveys showing that 47% of Italians would be willing to try cultivated meat if it were EU approved. This regulatory fragmentation reveals deeper philosophical divides about technology, tradition, and who gets to decide what people eat. Europe is taking a methodical, science-based approach through the European Food Safety Authority. America is experiencing an ideological split, and China is systematically building intellectual property dominance while others debate. The economic implications are staggering. Global venture capital investment in cultivated meat exceeded $3 billion between 2016 and 2024. Traditional food giants like JBS, Cargill, and Tyson Foods are establishing partnerships with cultivated meat startups, hedging their bets on the future. Let's talk about what this technology means for the real world and why it's generating such passionate responses on both sides. From an environmental perspective, the potential benefits are substantial. Life cycle assessment studies suggest up to 92% lower greenhouse gas emissions compared to conventional beef, 90% less land use, and 96% reduction in water consumption. For consumers, lab-grown meat offers several advantages. No antibiotics used in production, reduced contamination risk from pathogens like Salmonella and E. coli, customizable nutrition profiles, and absence of growth hormones. The generational divide in acceptance is telling. Recent European surveys show that 47% of Gen Z is willing to consume cultivated meat regularly, compared to only 21% of baby boomers. This suggests that as younger consumers become primary food purchasers, market dynamics will shift significantly. Restaurant partnerships are driving early adoption. High-end establishments can absorb premium pricing while offering customers innovative experiences. Companies are also developing hybrid products that combine cultivated cells with plant proteins, reducing costs while maintaining the meat experience. The pet food market represents another early opportunity. Lower regulatory complexity and reduced price sensitivity make this an attractive entry point for companies building production capacity. But perhaps the most interesting application is in specialty products that are difficult or impossible to produce conventionally. Cultivated foie gras eliminates ethical concerns about force feeding. Exotic meats could be produced without endangered species. Allergen-free versions could serve people with specific dietary restrictions. The next 5 years will determine whether lab-grown meat becomes mainstream or remains a niche technology. Currently, 2 companies have submitted novel food applications to the European Food Safety Authority: Gourmet for cultivated foie gras and Mosa Meat for cultivated beef fat. The EFSA approval process typically requires 18 to 30 months, meaning we could see the first European approvals by late 2025 or early 2026. The United Kingdom is charting its own course through a regulatory sandbox approach that allows companies to work directly with regulators to generate safety data. This could position the UK as the first major European market for cultivated meat. McKinsey analysis suggests that reaching a $25 billion market by 2030 would require 1.5 million tons of annual production capacity. That's infrastructure equivalent to 176 Olympic swimming pools worth of bioreactors, representing massive capital investment requirements. Cost projections vary dramatically depending on scale and energy sources. If facilities are powered by renewable energy and achieve industrial scale, price parity with conventional meat could be achieved by 2028 to 2030. However, if production relies on fossil fuel electricity and remains small scale, environmental and economic advantages could be limited. China's systematic approach to building intellectual property dominance adds another layer of complexity. While Western countries debate regulations and consumer acceptance, China is positioning itself to potentially control core technologies in cellular agriculture. The lab-grown meat revolution represents more than just a new food technology. It's a perfect case study in how innovation intersects with culture, politics, and economics in our interconnected world. The journey from a €250,000 burger to a 7-pound meal demonstrates that seemingly impossible cost reductions are achievable when the right technology meets sustained investment and regulatory support. The continental divide we're witnessing, Europe embracing methodical regulation, America splitting between innovation and ideology, China building strategic advantages, will determine not just the success of this technology, but which nations and companies control the future of protein production. What makes this story particularly fascinating is how it challenges fundamental assumptions about food, nature, and technology. When younger generations view lab-grown meat as addressing climate change and animal welfare, while older generations see it as unnatural, we're really witnessing a broader debate about humanity's relationship with technology. The revolution is already underway. The question isn't whether lab-grown meat will transform food production, it's whether different societies will embrace that transformation or resist it, and what those choices will mean for their economic and environmental futures. Thanks for joining me on Curiosity AI today. If this exploration of food technology and geopolitics fascinated you, subscribe for more deep dives into the innovations that are reshaping our world. Next week, we'll explore another breakthrough that's challenging everything we thought we knew about what's possible. Until then, keep questioning, keep exploring, and remember that the future is being written by the choices we make about the technologies we embrace or reject.